Hello, welcome back to my channel. This is part 3 of stoichiometry practice with mole conversions. So today it'll be mass to mass, which is basically the longest steps of converting in chemical equations. So with mass to mass, you have to convert from mass to mole, and then mole through the mole ratio, and then mole ratio back to mass. So it is a 3-step process. So when I give you a example, let's say I give you calculate the mass of, let's say, potassium nitrate if 15.5 grams of iron 3 sulfate, so Fa2SO43, is used. Alright, so again, same exact process that we've always been doing, but it's just one extra step from our previous video in part 2. So we have our grams of iron 3 sulfate, and we're trying to get to grams of potassium nitrate. So since it's both mass to mass, so you don't have to do this, but I highly recommend just finding the molar masses of each of these. So these are the two that we're worrying about here in our work. So I would find the molar masses first, because that's like a lot of calculations, and then whenever you need to use it in your train tracks, they have it ready to go. So I'm going to put this to the side here, grams of KNO3. So you should be able to already know how to calculate the molar mass of anything. So I would pause the video, find the mass of KNO3, and then unpause to make sure that you get the mass right. So the molar mass of KNO3 is 101.102. So from the periodic table, you have 1 potassium, 1 nitrogen, and then 3 oxygens. So like the mass of oxygen times 3. You add them all together. So this is what you should get. And then the grams of iron 3 sulfate should be 399.876 grams. So now we have these ready to go. We're going to put them somewhere in our train tracks. Okay, so we're going to start with our given. Include the units, always. That helps us our next step. We have grams of iron 3 sulfate. Drag that down diagonal. And then we do our numbers. So luckily we already have our grams ready to go. So I'm going to put 399.876. And now the opposite side, remember the opposite side, molar mass is always mass per 1 mole. So whatever it is, grams of anything, opposite side is always 1 mole of that compound. So that helps us in the next step. Now that we convert to moles, we're going to go through mole ratio, so that way I can get to KNO3. Mole of iron 3 sulfate, put that here. And then since I want KNO3, since I want potassium nitrate, I'm going to put that up here, and I'm going through the mole ratio. So mole KNO3. And then mole over mole, always look at the coefficients from the chemical equation. So I have 1 of iron 3 sulfate, and I have 6 of potassium nitrate. Okay, and then since I want grams of KNO3, I'm going to do one extra step. So the last part, the part 2 of the stoichiometry practice, we stopped here. Okay, now with mass, we got to go one extra step. Hopefully I have room here. Alright, so mole of KNO3, pull that down, and I want grams of KNO3. So this is a tempting mistake that you'll also pull the 6 down. Again, never ever ever carry the number down. Always carry down just the units. So again, grams of anything, opposite side is always 1. And then the grams of KNO3, we already found that there, so 101.102. Now we solve. And again, just to understand the units, grams of that cancels out because that's our goal to get to the new unit that we want. Mole of iron 3 sulfate, cancel that out. Mole of KNO3, cancel that out. And then I want the grams of KNO3, which is in the question. And now we solve. Again, as a reminder, we multiply across, so 15.5 times 6. Again, don't really worry about the 1. Times 6 times 101.102. That, whatever that is, divided by the bottom, 399.876. I like to put parentheses, especially if you're going to punch in the calculator at once. So if you're using like this calculator, which is a basic one, open parentheses, 15.5 times 6 times 101.102, close parentheses, divided by, open parentheses. It makes everything nice and clean. And it doesn't confuse the calculator with like PEMDAS or anything. Alright, that will be my final answer, 23.514. So I'm gonna round up 3 decimal places. And then our units is grams of potassium nitrate. Okay. Alright, so let's do another example, which you will try by yourself. Same equation up here. How many grams of, let's do potassium sulfate, is produced if, say, 7.32 grams of potassium nitrate is used. Alright, so since we got grams here, again, I would find the molar masses first, so it's ready to go for our train tracks. So again, pause the video, find the molar masses, then unpause, check your work, and then you will do the train tracks. Alright, so these should be your masses for what you want. So KNO3, K2SO4, these are the two that we're worrying about. And then now you have the masses ready to go for your train tracks. Again, pause the video, do your conversion, and then check your work once you're ready. Okay, so you should have gotten final answer 6.308, or super close to that, grams of potassium sulfate. So as you can see here, starting with KNO3, potassium nitrate, I converted that to moles and then go through the mole ratio. So according to the equation here, I have 3 for potassium sulfate, and then I have 6 for potassium nitrate. So so I have 6 in the bottom and 3 on top, and then I'm convert that to the grams of potassium sulfate. So by solving it, I since there's like numbers everywhere, so I would multiply the top, as you can see, multiply the top, multiply the bottom, then top divided by bottom, or put everything in parentheses, and then you should get your correct final answer. Okay, so that is it for the mass to mass conversion. It is pretty long, but this is the longest it will take. But I hope this helps, and hope you have a wonderful day. Thanks for watching.